Welcome to video lesson number 3. Hi, I'm Madhu Vadke. We have started with chapter 1, number system. By the end of today's class, you will be able to distinguish between terminating and non-terminating recurring rational number without actually dividing it. And you will also be able to represent real numbers, that is, rational as well as irrational on the number line. Now remember, in the last class, I had asked you to observe the denominator of rational number that has a terminating decimal expansion. Let us look at some more examples to find that special characteristics of rational numbers. Write these numbers as decimals. Pause the video and express each of these numbers in their decimal form by using the method of division. Now check your answer. 7 upon 8 in the decimal form will be 0.875. 11 on 25 will be 0.44. 3 on 20 will be 0.15. 5 on 6 will be 0.83 bar on 3, and 4 upon 15 will be 0.26 bar on 6. Notice that the first three numbers are terminating, and the fourth and fifth examples are non-terminating recurring. Let's look at the denominator. The denominator is 8. Find the factors of denominator. In this case, it will be 2 into 2 into 2. So I can write this as 2 to the power 3. Let's take the denominator in the second example and find its factors. 25 can be written as 5 into 5, which is 5 to the power 2. Third example, denominator is 20. Its prime factors are 2 into 2 into 5, which can be written as 2 to the power 2 into 5. In fourth example, the denominator is 6. Prime factors are 2 into 3. And in the fifth example, denominator is 15. Prime factors are 3 and 5. What do you observe looking at the prime factors of the denominator? We see that if the denominator of the rational number has factors only 2 or only 5 or both, then the decimal expansion of these rational numbers is terminating. In example 4 and 5, the denominators have factors other than 2 and 5. 6 has factors 2 and 3. Even though there is a 2, but there is another factor 3. In case of 15, even though there is one factor which is 5, there is another factor 3. So these two numbers turn out non-terminating and recurring. So we can now generalize what we have found. for a rational number to be terminating, q, which is the denominator, should have factors either 2 or 5, or it can have both. So we write it like this: 2 to the power m into 5 to the power n. So if the denominator, this is our rational number p upon q, where q is not equal to 0. So if this denominator can be expressed as 2 to the power m into 5 to the power n, in simple words, the denominator has factors either 2 or 5 or both, then it will be a terminating decimal. If it has any other factor other than 2 or 5, then the rational number will be non-terminating recurring. Let us now learn how to represent a real number on the number line. So we are going to represent rational as well as irrational. In your lower class, you have already learned how to represent a terminating decimal. In this class, you will learn how to represent a non-terminating recurring decimal. Now, in previous video, we have learned how to represent root x, which is irrational number, and x is a positive integer. In today's class, we will represent root x, where x will be a real number. Visualize 4.26 bar on 26 on the number line up to 4 decimal places using method of successive magnification. Start by drawing a number line. Mark the points from 0 towards the right side of the number line and show 4 on it. Now 4.2 will lie between 4 and 5. Magnifying the number line between 4 and 5, draw another line and start with 4 and mark 10 more points. Now you have divided the number line between 4 and 5 into 10 parts. So the number after 4 will be 4.1, 4.2, 4.3. Likewise, mark the number line. Now 4.26 will lie between 4.2 and 4.3. So draw the number line and magnify line between 4.2 and 4.3. Divide the number line between 4.2 and 4.3 in 10 parts. And mark the numbers as 4.21, 4.22, 4.23 and so on. Now 4.262 will lie between 4.6 and 4.7. So we will magnify the number line between these 2 points. So draw the number line, mark 4.26 and then mark 10 more points. And marking the 10th point as 4.27. Now mark the numbers after 4.26 as 4.261, 4.262, 4.263 and so on. Now 4.2626 will lie between 4.262 and 4.263. So we will magnify the number line between these two numbers. And divide it into 10 parts. Now mark the numbers between 4.262 starting with 4.2621, 4.2622, 4.2623 and so on. Number 4.2626 is here. So we have magnified the number line to show this number up to 4 decimal places. This number is non-terminating recurring number. So we have represented a rational number on the number line. Representation of root x geometrically, where x is any positive real number. We will represent root 9.3 on the number line. Start by drawing a line Mark 2 points A and B such that length of AB is 9.3. Now, mark another point C on this line such that BC is 1 centimeter. Now, line segment AC measures 10.3. Keeping the pointer at C and taking distance in the compass slightly more than half, cut arcs above the line and below the line. Without disturbing the distance in the compass, cut arcs to intersect previously made arcs. Now join the point of intersection of these arcs by drawing a dotted line. This dotted line cuts AC at a point. Mark that point as M. Now keeping the compass pointer at M and the pencil at A or at C, draw a semi-circle. Now we will construct a perpendicular to line AC at point B. So keep the pointer at B, measure 1 centimeter, keeping the pointer at B, cut arcs on both the sides of the line segment. Now use these points and keep the pointer at these 2 points to get intersection of 2 arcs. Join the point of intersection of these 2 arcs to point B. Now this line is perpendicular to AC and it cuts the semicircle at point D. Now this length BD is root 9.3. So we have obtained the length of the real number we need to show on the number line. Now we have to project this length on the number line. To do that, keep the pointer at B, measure BD and draw an arc cutting the number line. Mark the point where this arc cuts the number line as E. This point E is root 9.3. Now this construction is not yet complete unless you show the number line. So to show the number line, mark points 0, 1. So 0 is at B, 1 is at C. Mark the remaining points 2, 3 and 4. Root 9.3 will lie very close to 3, between 3 and 4. And don't forget to put the arrows. If you want to show the negative number root 9.3, then you have to keep the compass at B and mark on the left side of the number line. So BF denotes minus root 9.3. I shall stop here and leave you with this assignment. Make sure that the constructions in the first question are neat. We shall meet in the next video class with a new concept. We shall meet in the next video class and learn a new concept. Goodbye.